Welcome. This bootcamp is going to be Replication Advanced. The previous one was Replication Fundamentals. Remy and Mario are going to be building on what they talked about in the last bootcamp, and they're going to show you how to build a radar that detects supply containers and how to replicate that across clients. So without further ado, I will invite Remy and Mario to the stage to take it away.
Hey everybody, it's Remy and Mario. We are here today to continue our talk about replication, and this time it will be a bit more advanced than last time. Last time we gone over like the very fundamental of the replication with the door. Now we have a bit more complex system to show today, and this will be radar. Yeah, perfect. So we are directly into Workbench. I will show you already an example of what we will achieve today. We already set up the dedicated server tool. Today we'll use the dedicated server. I'll explain last time all these parameters, NDS and network resolution. Don't forget to go to the previous replication fundamentals to know about exactly what they do. And we will start. So the idea of today is to show a radar on clients of position of supplies, and the specificity of this is that it will actually I have 2 times the sound. I need to, of course, I have 2 sounds of the game. I need to kill them, but today is to actually talk about the radar. I'm just trying to remove the sound of the game. Yeah, exactly. So we don't need to have like 2 sounds. Yeah, thank you. For that, I've used campaign all-end, so conflict, mainly because conflict have already supplies placed on the map, so I don't need to actually place them myself. But yeah, so as you can see, we're going into the game. We have some radar, some widgets which display the position of supplies. As you can see on the radar, there is dots. All of those dots are one supply container. Those dots have 2 different colors. They have like this yellowish color, orange, which is like that means that the supply is streamed in to the client, so it's visible to the client. And you have those white dots that are the vehicle, the supply container that actually are not streamed in, outside of the streaming distance, and they are still visible. Because if you remember last replication fundamentals, we said that the replication distance is over 2 kilometers. It can be defined by the servers, but by default it's 2 kilometers. So outside of 2 kilometers, your client will not be able to see anything if you don't set up it specifically. Sorry. So I will show you by adding some track, so we will be able to see it ourselves. So if I'm placing here into the game, you can see on the radar that I have a dot just next to my blip, which is white, which was the truck. And if I come closer to it, you will be able to see it pop-ups, and then it's orange. So how to achieve that? For this, we used systems for that. We also used widget. I will go over quickly the widget. It's not the purpose of this modding bootcamp, but just so you know like how it's set up mainly. So the idea is that we have like a widget component, which every time update resource radar blips are called, it will actually create those blips based on the data that we pass as parameter. So we have like this array of data which represent like one blip, so its position, and we go over it, get the position, and display it with an image. So that's like just the radar displaying that you see with the blips. So now the question is, how do we send this data to the client, and what's the different way, of course, because there is not only one way to do that. So today we will go first with the RPC. So that will be like the most naive way, I would say, that you will do, is that you say, okay, I will create a system, which is this radar authority system. I just want to point out that, you know, if you don't know about systems, you need to set them up into the config file. So here I have my radar authority. I say that it's on both client and server. Here you can say the system location, so both client and server, so it will be visible on both, because we need to send RPC from server to the client, so we need both of them. And we have the proxy system, which is just the one that's updating the UI that we saw before, and this one is, of course, is only client, because there's only UI on the client, not on the server. So we just need it on the client. So for the first version of the system, we have this authority RPC system. Normally when you set up your system, you will set it up in the config, you will inherit from game system, and then you will have some method which is on update, which will be called depending on the system point that you set up here. Here it's the radar authority is fixed frame, so it will tick every fixed frame, so every 30 FPS. And here what do we do is that we find the replication node, as we discovered last session. RPL node, you can get RPL node from any item. So here we get like the item ID of ourselves, of the system, then we have the system RPL ID, and then we can find the node from it. And then from the node we can get the role. This role we can check if it's proxy or authority, because of course the system were on both client and server, so we want only to tick on server, not on client. So here we just check if it's actually the client, and if it is, we return. Then we have actually the update radar blips. So this function will update. We have a list of resource components. So what we do with the resource component is that we gather them manually by calling register resource component. So it will be like the method that will actually insert into it. I think if it's us, we use modded on the resource grid, and because how resource system works is that you have some grid, and when it's inserted into the grid, you can know that it has been inserted into the grid. And when it's inserted into the grid, what we do is that we get the system, we find the system, and then we call a register component. And the same when we remove it from the grid, we call unregister the component. So the system will insert into this array, which is like the list of all resource component in the world, because we're on server, so we have access to the whole world. So then when we update the radar blips, what we do is that we count the number of resource components that we have, which is in the world, and we will create our data based on that, of course, because the idea here is to send some data on to all the clients about the position of those resource components. And as well, we set it up that we send also the RPL ID of those components, so we can find them back on the client. So here what we do is mostly simple, is that we create this resource data blips, which is this array of data that we want to send. We gather the resource component. We say, hey, this data have this position set. This resource component, so when we set the resource component, we just find the RPL ID of it, and then we not this one. We just afterwards, when we have all this data set up in this array, we will send our RPC to the client. So how do you set up an RPC? It's pretty simple. Systems are owned by the server, so that means you can't send RPC from client to server, but you can send RPC from server to clients. So in this case, what we do is that because we send RPC every fixed frame, we make it unrailable, because we don't need make it railable, because we will send every frame. So that's the most important, and we of course make it broadcast, so it can be sent to everyone. And then when the client receives it, you just set this array back to this. So now you will think like, okay, I can send this data, but this is custom, like class. How I can send custom class? Because if I create my custom class myself and I send it over the RPC, it will give me an error saying that you can't do that. Why you can't do that? It's because you need to define some methods on it, some specific replication methods. You can find, I just want to remind everyone that you can actually find documentation about replication in the tools directly. Yeah, exactly. So I just want to show you that you go to the Steam, you go to the tools, and you don't go into the docs here, but you need to go into Workbench, and here you have some docs. And here you have like the Fusion script API public that you can extract here, and then it will actually you will be able to access it here, and you will have some index HTML here that you can open, and here this is like the replication. So if we go into some replication overview, you have all this code, you can go over it yourself. There is not only replication. I want to remind everyone that it's also there is also other docs. But what's what's the most important is that we need to understand how we can send our custom class over the network. So for that we have typical methods that we need to create for that, and this is the encode, decode, snapshot compare, prop compare, extract, and inject. So if we go here in the documentation, it says exactly why those methods exist and how they are used. We can go over it quickly, but the first one, which will always be called, is the for RPL prop, is the prop compare. It will actually check, hey, actually is my snapshot value the same as my current instance value, and if it is, then don't need to send anything. Then the second thing is to extract the value, so we get the value from the instance and write it into the snapshot that we will have. And then the next one is to encode. So here it goes from the snapshot that we created to sending it over the network. Because if we take an example of a Boolean, in the snapshot it can be 8 bits. We don't really care, but over the network we can only send 1 bit. We don't need to send 8 bits. So this is like the step where it will actually encode it into like the packet to send over the network, and you have exactly the same on the other side, where you have like decode, which goes from the packet to the snapshot, and then you have the final inject, which goes from the snapshot into the instance. So if we look at our instance, this blip data, we have so the position, as I said, the resource, the containers have one position, and we have also the RPL ID. If we look at it, the first thing is extract. So here we will actually have its static methods, and it will pass as parameters the instance and the snapshot. So here what we do is that we serialize the vector inside the snapshot. So here specifically vector is 3 floats, so it's 12 bytes. So here we made like some static const variable, so we don't need to write 12 hardcode 12 in the code. And the same for RPL ID. This is 4 bytes because this is 32-bit. So we done the extract. Now we need to encode it over the network, and here we actually don't have any specific thing to do. As I said, for Boolean to write only 1 bit, here we can just write what we wrote into the snapshot into the packet. So here we can just call serialize method, which on the snapshot, which passed the packet and the number of bytes that we want to write. And as I said before, vector is 12 bytes, RPL ID is 4 bytes, so it's in total it's 16 bytes, so we just write 16 bytes. Then we have on the other side, what we want to do is decode, so the same as before, but now we go from the packet into the snapshot, and then we have the inject method, which are the same as I said before, but now we go from snapshot into instance. You're probably thinking about like what are those snapshot compare and prop compare. This is for RPL prop. If we want to create a class that is sent only over RPC, we don't need to define those. So we could like I mean, you need to define them, but you can do like return false or something like that, because they will never be used in case if it's a snapshot, if it's a RPC, sorry. But in this case, we created them because we will use it later. This is the first, usage with RPC, where we send only, over the network, we send over the RPC. So we don't need snapshot compare or prop compare, but later we will have a RPL prop. And so RPL prop actually require those two to be set up, otherwise it will not work. So here we set up it like this, and that's kind of the only thing that you need to do. It seems a bit complex at first, but it's pretty simple to do. The most important is to understand like how many bytes actually are. And you will probably think like, okay, but if I have, I don't know, imagine here I have another class, custom class that I created. Here I will do a blip data, but it could be any kind of class. Here you can just, call the static method on top of it. So here it will be like, radar blip data encode, and then the rest here. This makes that if you have another custom class and you want to write, this encode for it, you can just call again this method on this other class. So here we define how we send this data over the network automatically, so we don't need to, write it ourselves here. Here it will automatically, like the engine will automatically call those methods that we define to send it over the network. So here in our solution, what we do is pretty simple. We receive the data, we set the data into resource radar blips, and that's kind of it. Now we have the radar proxy system, which is like the UI part, and this is pretty simple as well. What we do here is that we call update radar widget every frame, and every frame we will gather the data from this system that we got. So in this case, we just call update resource array doublets with the data that we sent. So in this specific solution, the problem is, of course, that you will send every frame, every fix frame, some RPC. If you remember last session, we also talked that replication is only tick on fixed frame. So if you, for example, send every frame some RPC, it will only be sent in fixed frame. So in this case, we only send one RPC with all these big data. That means imagine you have 100 of things into this array. That means there will be 100 of resource radar blip data sent every frame for each client, which can be insane. But this is like the very basic or the most naive way that you will set it up. It's this way, but at least I mean it works. That's one point. So yeah, this is the first version that we actually set it up, and now we will see the second version. So the second version, I will set it up so we can have this. The second version actually use RPL prop this time. So instead of sending RPC every fixed frame, we will actually send, I mean, we will not send ourselves, but we will update the data every fixed frame as well. So for that, I have this other settings. Resource radar. Yeah, so here I have this RPL system, which is the other one. Here, how most of the things, most of the setup is almost the same. Like here we also have the same thing, so we also gather the resource components with exactly the same idea as before. We do almost the same thing. The difference is here, where instead of sending an RPC here, we actually have an array of RPL prop. As you can see here, we have ref RPL prop. So that's why I was saying before is that if you look at this blip data, now that you set up as RPL prop, you need to define those snapshot compare and those prop compare. Why? It's because as it's explained already in the doc, is that what replication will happen is that it will create a snapshot of the current state, and it will compare those two together with prop compare. I mean, it will compare the current instance with the, what it is in the current snapshot to see, actually did it change? And if yes, then it will continue. It will continue to proceed. Otherwise, it will just stop because that's the same data. And the same on client snapshot compare. It's to, as it say here, it's to determine whenever the change have occurred. So if you check, I mean, it's need to check if the snapshots are the same, and if not, that means that the client actually have different snapshots, so we need to apply the snapshot with inject as we decided before. So yeah, we set it up this way. We can try it to see if it actually works. Of course it will work, but the end result will be almost the same. It will just use this RPL prop variant instead of the RPC variant. You need to understand that this is very, very basic, in a way that we force to send it every frame. Just after we'll talk about what could have better, how could we set up better, without like sending it every frame. But for now, what we do is almost the same as before with RPC, it's just that we use RPL prop, so we let the system to actually handle the case of, oh, it's the same data, so we don't need to send it over. Because before with RPC, there's nothing that was set up in a way like, oh, if it's the same data, then just don't send the RPC, because why I will need to send the RPC if it's the same data? Where here we actually need to, we don't need that. The replication will call those snapshot compare method and will automatically check. So as you can see it here, it's mostly the same as before. The radar works correctly. We have some blips around, and all of them are showing correctly, and we see all of them. So if we go a bit further away, I think but the sorry, the truck will actually disappear and will become white at some point. Yeah. We can see as well that if you don't know, we have debug camera in the workbench, and you can use it by Control-Alt-C, and then you can fly over, and you can see it here that we fly over and everything is showing correctly around the world. So the radar automatically updated, and we see everything updated correctly. So mostly there is almost no difference, I would say, compared to the other version. This one just uses RPL prop, so it will be the same forcing, where you will every frame gather the data, update the data if needed, and replicate it with replication bumpy. This go over the whole idea of this example is to show that you can send data, or how you can send data of things outside of network distance. Because if you can look at the radar, what we will see is that there is a lot of orange points, even if they are very far away. And this is because how supplies is made currently in Reforger is that they are made as unstreamable. This means that they are not streamed out after 2 kilometers, but they are always streamed into everybody, to everyone, even if you are far away, for technical reasons for now. So that's why there is a lot of orange point and not a lot of white points in this case. We can take a look. I can show you quickly what is the streamable. I think we already gone over this last time, but just to remember that you have like this streamable here, which means that it's unstreamable, which means if it's visible, which means that whatever distance you will be from this this entity, it will never stream out, so it will always be visible. This is most often it's used for managers in the world, like those managers entities, but it can be used for something else. The most important behavior of this is that if you have two entities attached together, and one is streamable and the other one is not streamable, what will happen is that the wall both together will become unstreamable. So like the unstreamable is always taking priority compared to the streamable. If I will show you an example, it will be easier around here if I find something interesting. Yeah, this one for example. So you see, for example, here we have like this campaign prefab, this supply cache here. No, I don't want that. but we have this supply cache, and you can see like this RPL component is enabled, which means like it will stream out from the distance a lot of RPL component. But in this case, if one of them, if I click on, yeah, for example this one, I can say like, oh, it becomes unstreamable, which means that if it becomes unstreamable, it will make this whole prefab unstreamable, which is very like, you should not do that. And you particularly never do that most of the time. And if you do, that means it's very specific, and you should not do that for all entities. But this is just to show like the behavior of, if you put something unstreamable, even in some hierarchy, it will force the whole hierarchy of entities being unstreamable, which can be very bad for the gameplay, because you will start to like make unstreamable everything in the game. So to go back to this, it's mostly the same as before. As I was saying, you have a RPL prop, and then it's displayed. Of course, you will tell, yeah, but I want something maybe a bit more like optimized, because in this case, yes, I have this number of components that I want to replicate, and this number maybe will never change, or maybe it will change, but I want to not send all those positions all the time. So of course there is always like optimization. In this case, we made it very simple for this example, because the idea was still like for people to understand the concept behind it and how you can do something like this, and not about like exactly how to optimize at the perfection this specific behavior. If you want to optimize it, of course you will need to do something like don't send if you don't want to send it, and stuff like that. But I want to point out that RPL prop, if it's on an array, it will resend the whole array if something has changed. So as soon as you have one of those elements in the array that actually changed, so one position, it will actually send the whole array. So imagine if there is like 100 items inside it, and you have one of those that has changed, the engine will actually send the whole array again. If you don't want that, for example, and if you want to introduce your own method to do that, or your own system to actually handle that, because the engine doesn't, but you want to be very specific in this case, you know how it will happen, and you know that it will never change, or you will do something like this. You have encode delta and decode delta, which is here, and those are actually a way to send over the network only the changes. So when you will write about it, when you will write something with this encode delta and decode delta, you have like the old snapshot, you have the new snapshot, and you have the packet. And the idea is that you go over, in this example, if we have this array, what we will do is like, okay, for this encode delta, I will check if this element changed, and if not, I can skip it, and then do this for all the elements, and then in decode delta do the other way around, like knows the count, and you know, it's very specific, but that's the idea. Like you have again something on top of it, which are like encode delta and decode delta, which are like specifically made to make those huge classes, or those huge like data that you want to send over the network between two snapshots, make it more performant with less network. That's specifically made for that. Those two, because in this case, what you will want to do is that you want your array never to change or never like to resize smaller than the old one, because you don't want to change, like you just want to resize it bigger. And you can do something like, oh, my radar blip data have some boolean saying if it's actually used or not, or use the RPL ID for having that like as invalid. And you can send the delta of like, oh, I change only this index in this array, so just send this, and I only change this one, so send this, instead of sending the whole array, which is doing it by default. Comparing those two implementation, there is not much like the differences. Like here it will, pack the whole data in one go. Here it will actually compare the data before saying edit. You could technically, of course, do it yourself, comparing. Here you could be like, oh, has changed, false, and you will compare like, oh, is my old blip data position is the same as the new one or different? If so, if it's changed, then, or if the position has changed. So I'm just doing pseudocode because it will be something like this. Oh, the position has changed, and then true, and then here you will be like, yeah, if it's actually changed, just send it over the network. Yeah, that's most of the what we wanted to talk about. I don't know if Mario, you have like some precision or something that you want to go over.
Maybe a warning if you are like dealing with arrays on RPL props. Where's the?
Yeah, this one.
Yeah, if you are dealing with an array with complex types or whatever, like in here in an RPL prop, be careful on trying to rely on an element that was part of this array before. So let's say that I have in another system something like this. And let's say that at some point I assign to this an element that was part of this array. What could happen here later on is that first notice, that this is a weak reference, so it means it's not going to hold a strong reference to like the element here. So whenever we call a replication me and we receive it on the client, what's going to happen is that the replication system is going to basically recreate this whole array from scratch. It will remove everything from it, it will clear it, and then it will create each element one by one. So that means that this radar thing, it will always have new elements every time we replicate. So that means that no, whatever we were holding here is going to become null. So that's probably one very hard to debug issue that you might find yourself with if you are not aware of this. The other thing is that if you hold a strong reference, now this will become null, but what you're going to have here is not going to be related to what's here anymore. So that's just something that you need to be careful about, because it's basically, when dealing with replication on scripts, is one of the hardest to debug bugs. So that's kind of like a gotcha that you have here.
Yeah, exactly. The array will be cleared, so be careful of the data that you put here, and especially how you use it. Here in this example, we actually counter that by sending the data every frame, so we are sure that like the data will not change and we clear everything. But in the case that you want to do something more complex and you have a reference around and everything like that, yeah, you need to be very careful with arrays, replicating arrays. I think yeah, the only specific thing here when you create your encode and decode. You have kind of two ways to do it. You have, if we go into some encoding, yeah, exactly. This is the perfect example. The idea is to try to minimize the number of calls that you do every time, because this is used for replication. So imagine that it's used for each connection on the server every time it sends over the network. So if you have 100 of them and 100 connection, then yeah, it's become like 100, like squared of 100. So it can be very, very heavy. So most important is try to reduce the number of calls that you do in those methods as much as possible. So you can see the differences here. For example, as some map marker, where extract here actually maybe not extract, but yeah, here it's kind of okay. But normally what you can do is that you can use serialize in encode and decode. You can do it for each no, this is complex. Each member of the class. I don't know, I forgot about this one. Yeah, so you can see it here, for example, that like here when we serialize, when we encode the packet, we do each time like encode int, and the number of members. The problem is that we create a lot of call instead of writing once or one call. So this is what we do here, is that we calculate the number of actually bytes we will need to send. We will need to serialize in one go, and then we just say, hey, serialize this number of bytes. I don't care. I don't want to call one by one because I want to be as fast as possible. The only place that you can't do that is, of course, extract and inject, because you inject into a specific place in the instance. But other than that, yeah, it's probably you need to try as much as possible to reduce the call here, because that's a lot.
This sample that we made here is also going to be released on the official GitHub, so you will be able to play with it, to experiment with it, extend it, etc. And we will also be providing other ways of doing the same thing on that as well. So if you want to experiment with this, or if you want to use it in your mods or any other purpose, feel free. It's actually quite easy to modify for using it on any entity or anything. It's just based on positions. So you can use it for like detecting people in your faction, or if you're playing in some milsim scenario, to detect people on your squad or your team.
Yeah, it's exactly the same system as markers. Map marker system uses the same thing as we did today almost. Yeah, so thank you very much, guys. Thanks for being here, and we'll see you later on Discord. Yeah, thank you.
Thank you. Have a nice day.
Have a nice day. Bye bye.